Welcome everyone to today's Eawag Seminar, the people in the room and also online. And the speaker of today's seminar is Professor Sarah Bell. She's the City of Melbourne Chair in Urban Resilience and Innovation at the Melbourne Centre for Cities in Australia. And her research addresses urban resilience and community engagement with infrastructure, especially related to urban water systems. And in her research, she mostly relies on social science to better understand how people, technologies, and nature interact in such a system. So welcome, Sarah Bell, and yeah, the floor is yours.
Thanks, Leanne. It's really very pleased to be here in Zurich and at Eawag. Hello to everybody online. Excuse me. So the work that I'm going to be presenting today is work that I completed in London in about 2020. So it's a bit, for me, kind of backwards looking work that is, has been completed for a few years now. But the reason why I still wanted to share it with you is that it gives a bit of an example of how a few projects have built up to a particular set of methods for engaging local grassroots communities in infrastructure design and provision. And the other reason is that this is work that we, so myself and 4 of my collaborators have just recently written up in a book, and I'll give the details of that book. It's coming, it's not out yet, it's in production. So the book will be out with UCL Press in April next year, and it's an open access publication so everybody can download it. So it's a bit of a preview of what you might find in that book if you were interested. And hopefully, in any case, it will be of some interest and relevance to your work here and to other research around water infrastructure and infrastructure more generally. So yeah, as Liliane mentioned, my work now is much more focused on urban resilience in a more general context, and specifically working with the City of Melbourne. So it's been quite a change of direction for me since I started working at the University of Melbourne in February 2021, and it's also been, a bit of a strange time to start working, to start building up new research connections and new projects. I am Australian, but it was moving back to Australia after 16 years of working in the UK. So that work is all still building up. Hence, we've got a bit of a retrospective in the seminar today. And there we go. So the structure of the talk is that I'll talk about an initiative that we started in about 2013 at UCL, University College London, called the Engineering Exchange. That was an initiative to help to connect local communities who might have technical or particularly environmental questions or issues that they were wanting to work on with researchers, and especially engineering researchers in the university. Some of you might be familiar with the European model of a science shop. It was more or less a science shop for engineering at UCL. And then that helped to build the foundations for what for me became a research fellowship from the Research Council on bottom-up infrastructure. So more broadly, how do we engage communities in infrastructure provision? And then I'll give you effectively 3 case studies, and these are 3 of the 4 case studies that appear in the book. The first one, Engineering Comes Home, was looking at how can we engage local communities in questions about the water, energy and food nexus. The second one was about air quality in a particularly deprived and polluted part of London. And then the third one was in collaboration with Imperial College, the British Geological Survey, and Oxford University looking at community water management for a livable London. So the engineering exchange, which provided a bit of a foundation, as I said, for this work, was a network of engineers across the Faculty of Engineering and the Faculty of the Built Environment at UCL. And we really just provided a front door and a service where local community groups who had a particular question or might be in some form of conflict with their local government or with their landlord could come to us for technical support. So, and it was also a way of helping staff to also connect their work into, real life, very meaningful contexts in London. It ran for 6 years. I was the director. That's me looking younger and happy. Well, not happier necessarily, but this was the engineering exchange team. We then had co-directors from different departments at UCL, a steering committee which included representatives of community groups. So it was quite a small initiative, but we were able to undertake a lot of projects with many different partners. I haven't a different slide, I have all of those statistics, but we did projects with communities on air quality, traffic, heating efficiency. There was an idea from a local community group that wanted to use London's canals more for freight transport to try and get trucks off the road. A whole bunch of issues, including green infrastructure and some water related issues there. Our very first project, and this is also a case study in the book, was looking at demolition and refurbishment or retrofitting of social housing. So this was an example of the social housing tenants who were represented by the London Tenants Federation, were facing in social housing estates all over London. People who lived on those estates were being faced with the demolition of their homes. So whether it was local government or real estate developers would come in and say, we're going to improve your estate. But for many people, that meant that their homes would be demolished, which would, obviously creates lots of disruption and upheaval for them. And where the technical kind of questions come in is that often that would be justified in terms of your building is very old and run down and it's very inefficient in terms of energy. We will knock that down and build a new energy efficient home, and that would be better for the environment. And they really wanted to question that premise of, well, what is the technical evidence as to the benefits and the costs of demolition or refurbishment? And certainly at that time in 2013-14, the idea of embodied carbon wasn't really something that was considered in decision making, and it's still, is only a relatively new concept now in council or government decisions. So they were asking the question, well, what about all of the resources that it takes and all of the carbon that it takes to build homes? What happens when you take that into account? So we did, effectively, and it was an independent peer-reviewed report of the evidence looking at the kind of full life cycle costs and benefits of demolition or refurbishment of social housing. And that then gave them a weighty peer-reviewed technical report. It also gave them fact sheets and policy briefing notes that they could then use in those conversations and in their interactions with local government, the mayor in London. And it contributed, they could then use that as evidence for their own submissions into policy and planning processes, so that they had a much stronger evidence base to argue for a more democratic approach to decisions about demolition. So demolition and refurbishment and this whole range of other projects gave us lots of experience in how to do this work with local communities. And then that helped to make the case for my research fellowship, which had the title of Bottom-Up Infrastructure. And this was responding to a call from the Research Council about a program that was called Living with Environmental Change, and they wanted to look at these, how do you engage communities? Well, one of the aspects that they wanted to fund research in was engagement, bottom-up approaches and engagement with communities. And so my research proposal was to try and connect infrastructure resilience with community resilience. And certainly in the UK policy context at that time, and I think it's still really the case, and also in academic context, when we talk about resilience, we talk about those two things as separate, that there are things that you can do socially with communities to improve their resilience to disasters. There are things that engineers do to better design and manage infrastructure resilience, but the two things are quite separate. And so the hypothesis of this research was, what if we could actually engage communities with infrastructure? Would that then give you more resilient infrastructure? And does it help communities to be better prepared for disasters? If nothing else, they might have a better understanding of how infrastructure works. And they might also have a better understanding of how their kind of behaviour and decisions impact on broader urban systems. So that kind of gave a bit of an umbrella to then undertake a series of different smaller case study projects, some of which were funded in different ways with different collaborators, to explore these issues of, in particular, can you develop design processes that engage communities? And our first effort really at this idea of co-designing infrastructure was the Engineering Comes Home project in collaboration with those folks. So the collaborators there are some postdocs at UCL, other colleagues, academic colleagues at the University of Newcastle at the time, and a couple of small startup tech firms. II Lab were based in Berlin, and we're very much a tech software kind of software engineers. And OTA was a startup looking at rainwater harvesting and sort of smart rainwater harvesting controls. So the Engineering Comes Home was pitched at this idea of the water, energy, food nexus. So I'm sure you're all familiar with this interactions between, big infrastructure systems and the potential for infrastructure interdependencies and resource interdependencies, and the idea that, to run a water system, you need energy, particularly for thermal power systems, you need water for cooling. Our food systems rely on water for irrigation and also energy for pumping and energy to transport food. So, so this idea from a big kind of global resource perspective that all of what we think of as complex challenges in and of themselves are actually interacting, and then that just, magnifies the challenges for management, and it also magnifies the potential consequences when you might have interdependent multiple systems failures. So the water, energy, food nexus was something that was getting quite a lot of policy attention at the time, but the way, and attention from the research councils, but it was very, typically talked about in those big infrastructure systems, big technical systems terms. And what we wanted to do was just to kind of flip that on its head and say, well, where else do water, energy and food come together? And of course they come together in our homes, in our everyday practices and our everyday experiences. So, cooking a potato, for instance, you boil a potato, you have water for your cooking, you have the food itself, and you have the energy for that. So, so we wanted to look at the the infrastructure from the bottom up, from the demand side rather than big supply side challenges. And then the premise became, well, if we want to find out how people use water, energy and food in their homes, we want to come up with some alternative propositions that might be more resilient and sustainable. Doesn't it then also make sense to engage them or to have them involved in those design processes rather than just going in, extracting the knowledge and heading off and doing a design or an engineering analysis elsewhere? So that was the kind of justification for why we might want to involve communities in those design processes. And from our design research perspective, we then also wanted to develop and test methods and tools for designers so that we, with our very well-funded research project, could develop methods that then others in other contexts might be able to apply more efficiently and more cheaply. So we developed a 3-stage, it's a 6-stage design process centered around 3 main design workshops. So the first 2 stages of our design process, and so we'll see this process recurring in the 3 case studies. But first of all, we needed to sit down with our project team and our collaborators and agree a set of aims. We then went into communities to find out more about them. So classic, at the postdoc who did that work, her training is as an anthropologist, to really find out where communities are at, what their needs are, what their aspirations are, what their history is. Then to bring that into a workshop where we could get an idea about what are the requirements for our engineering system that we might design with people, what specifically are their values, what are things that they're concerned about. And then to take that away to do some analysis, and we came up with a short list of options that we thought, technical options that we thought might fulfill those needs and requirements, went back to the community and worked with them to analyse those options. And that analysis included a software tool that enabled communities to do very quick life cycle assessment of the different options. So when they were assessing technical options, they could think about, well, which one would be safer for, which one would be more robust in our particular environment, which one would be safer for our, children playing, or whatever their kind of, everyday knowledge assessments were. But we were also able to help them to see what the life cycle assessment implications of their decisions would be through our software tool that we designed specifically for that context. So they analysed some options, they chose a particular technology that they wanted to pursue, which was rainwater harvesting. So in between there, we then installed a prototype rainwater harvesting unit so that people could again get more knowledge of what rainwater harvesting was, how it worked. And then we developed another piece of rainwater harvesting software that people in the 3rd workshop could then come to a more detailed solution of what a rainwater harvesting option might look like on their estate. So that was, again, standard kind of engineering calculations, and went into that software so that people could take into account things like, we want to have a rainwater tank next to the car park so we can use the rainwater to wash our cars. But they could also see if we have 7 rainwater tanks on our site, then we are reducing runoff into the sewers by a certain amount of volume, and that has a benefit for the bigger infrastructure. So yeah, so this is the estate where we were working, the Meakin estate, social housing, but with some mixed tenancies. There's been some privatisation of social housing. So some people would own their flats, others would be renting from a private landlord. And yeah, so this is some of that detail that I've already given you. So we developed, along the way, we developed various tools to support these conversations in the workshop. So one was you can see here someone using some hexagonal tokens that we use to help people to be able to tell stories about their estate and about resources, but also to think about the hexagons were designed so that they could show connections between different resources and different technologies. So that helped us to, as a research team, to define those requirements, to then look at some technical options. As I mentioned, these were the options that we came up with that we thought might meet the needs that people were talking about. And then again, into that second workshop, we had the calculator, the software, you can see people using it there, and fact sheets about basic information about each of the technology systems. You know, this is an example of the fact sheet, and this is a screenshot of the calculator so that people can make various changes about this was to look at analysing the option for a wormery and a food garden. So people could adjust how many flats would be involved. They could adjust, various elements that would then give them an example of what impact that would be on waste, what impact that would be on water, and other elements. And then this was where the smart rainwater harvesting collaborator came in. They separately had funding from an Internet of Things program in the UK to look at rainwater harvesting on Internet of Things protocols. So they installed their prototype, and then we ran our third workshop so that people could start to come up with a design for a rainwater harvesting system across that estate. So at the end of that, we had all of these different tools. We had our kind of 6-stage method, and the various tools that fed into that, and we pulled that all together on a website that is still available. It's been archived in the Wayback Machine. But yeah, you'll see that has since further developed. Our next project was really to try and test this idea of, can we do this with much less resources? So we then still funded through an internal university program, but this, our next case study had 10% of the funding of the our first project. So we didn't do any software development in this, but we still moved through those same steps and used some of those similar tools in a different context to look at air quality. And so again, these are some UCL collaborators and the community-based collaborators. It's in the Somerstown neighbourhood in London, which, for those of you who know London, it's the community that lives between Euston and King's Cross Station. So the two nationally and internationally significant rail hubs. It's an area of constant construction and development. It's also an area with some of the most deprived communities, or people living with multiple deprivation is the language in the UK. And so this is an area that really the concept of environmental justice is very evident, that it is the poorest communities who suffer the most from environmental pollution and disruption. And in this area particularly, a lot of the environmental disruption, noise and air quality issues are around construction to improve connectivity to Europe and other parts of high-speed rail to other parts of the UK, so that people like me to Paris more quickly. The people who live in that community have no interest in going to Paris necessarily, and whether you can do it 20 minutes faster doesn't have any benefit to their lives, but they're the ones who pay the price for that constant kind of development. So colleagues from our laws faculty had been working with local community and the Environmental Law Foundation to run an inquiry really to explore these issues of environmental justice. And air quality was something that came up as a high priority. And so then we followed on with that work with a more technical project looking at air quality, and specifically the neighbourhood forum. So in the UK, the lowest level of planning documentation or plans is something called a neighbourhood plan that can be adopted or really developed by a local community. It still has to be consistent with the higher levels of planning, like the local plan from the local government, but it provides an opportunity for local communities to have a bit of control over development that happens in their area. And the local neighbourhood forum, who were looking to revise their neighbourhood plan, wanted to look at, well, what measures might they propose in their local plan to help improve or at least stop the decline of air quality in their area. So again, we, were structured around this same process of setting our aims, finding out more about the community, and our 3 workshops with various work in between and various tools coming in along the way. And one of the main the main option or the main piece of work that actually the community decided they wanted was to really have a detailed technical assessment of what is the actual quality of air. There's a lot of, this is partly because of the high levels of development. There's actually a lot of air quality monitoring in this area. The community wanted some help in making sense of all of that. And all of those developments have air quality impact assessments done. They wanted to go back and say, were they sensible? Were they done to a good standard? What are the outcomes compared to how things actually happened? So they really just wanted some independent technical reviews of those planning documents and publicly available data. And so there was assessment to show air quality is poor in Somerstown, but it has been getting better actually over time, and there is some variability in the neighbourhood as to quality of air in various different streets. They also wanted to look at, well, the part of the air quality problems is because of a major arterial road. The train stations generate some, but not much pollution. But there's also local energy centres and other sources of pollution. And so essentially what the main outcome of that and the most useful outcome was that we had an air quality consultant who we were able to pay a small amount of money to do that review and to go back and to give the community some reassurance where developers or plans had been done well and others that weren't done to a high quality, and they could then have some technical backing to be able to query their local council and to hold local developers to account, and to actually change some of that monitoring, change places where, change the actual locations of some monitoring to get better, more consistent coverage. So they did come up with also some recommendations for things that could go into that local plan. As it's happened, the neighbourhood plan process, they haven't been able to pursue that, but nonetheless, they still have been able to raise the quality of accountability really for local government based on having this access to this technical review. And then the third case study was part of a major project funded by the Natural Environment Research Council, led by Adrian Butler at Imperial College. And this was an interesting funding program. The Research Council wanted not to fund research, but to fund impact projects. And the funding program was called Regional Impacts of Science for the Environment. So it was intended to be very local. So Imperial College and British Geological Survey have very detailed and sophisticated models of groundwater of London, of the Thames Basin, and so really wanted to use that as their foundation for an impact project to get stakeholders involved, from the water companies, the government authorities, house builders, lots of stakeholders, including local communities. So they came to us wanting to us to bring our kind of expertise in engaging communities in these issues. And we worked with, so this was it's still an ongoing program, to really look at water management in London, but not starting from here's water science and trying to push it onto stakeholders, but saying how can water science help to meet objectives for a more livable city, and how can we make that a more participatory process. So the estate that we worked with are neighbours to the Kipling estate. They have the same tenant management authority or organisation, and so it's the Kipling estate. It's similar to Meakin, dense inner urban environment, social housing, but with some privatisation of that. And residents there wanted wanted to build a garden on a rooftop. So what you can see, these are the low-rise housing. So semi-detached, 2 to 3 stories. But here are 2 high-rise towers, and those 2 high-rise towers overlook what is that's a single-story garage block, and it has a very big concrete rooftop. And when the estate was originally designed, that was designed as social space, so that people could, these walkways from like the 2nd story of the tower blocks would spill out onto this area, and you could use that for play space or what have you. But for various reasons that are kind of a bit too common in social housing management, that area had been blocked off and residents hadn't been able to access it for many years. So they were just overlooking this empty concrete space, and they really wanted to reactivate that by putting a garden on it. Because they knew of our work with the Meakin estate, they came to us and said, we want to build a garden, but we need to have some water to irrigate it. And so I went to investigate that, and I looked at this space. It's about 40 metres by 40 metres. It's a big space, and thought, oh, this could be a rain garden, and that could have actually a fairly significant impact on keeping all of the water from that catchment out of the sewers. This is a very congested area of combined sewer overflows and actually local surface water flooding. And so if we were able to do that, again, to help the community to design their garden, but bring in engineering considerations around surface water runoff, as well as what would they need for rainwater harvesting to irrigate the garden, then we might be able to get water benefits on top of the community desire for a garden. And from our, Research Council perspective, this is a way of getting the science of water management into creating a livable city. So we really, again, focused on that same process. We developed different tools. There were some slightly different things that we were wanting to consider. So we tried, I'm not sure we were necessarily successful in evaluating this idea of infrastructural literacy, that if you involve communities in discussions of designing infrastructure elements like a rain garden, does it actually increase their understanding of how water infrastructure works in their city? We, in this process, included people from the water company and from the local government, because at the outset we had some ambition that that might provide a source of funding. So if the water company could then see the benefits, they might actually fund the garden itself. We included the gardeners from the estate because inevitably they would be involved in maintaining it. And we wanted to have a more explicit effort to build in governance of the garden itself, so that when we left, there would still be some organisation to take the ideas forward. So yeah, this similar kind of 6-step process. The first one we did what we called an infrastructure safari. So yeah, also we'd set the aims. The anthropology postdoc had been out to kind of find out more about this community, into the archives to find out more about the structure. One of the activities that we did on the first workshop was an infrastructure safari where the people from the university and stakeholders could walk around the estate with community members. They could point out, oh, this car park floods when it rains. And so then the drainage engineer from the local government could say, oh yeah, that's because we know we've got an undersized, network here, or we could point out, oh, that building over there has a green roof. This is how green roofs work. So it was a nice mechanism for exchanging that local and technical knowledge. We played some games to, again, find out this, what do people value? What do they really not want? And so they really valued being able to grow food and being able to have places for their children to play. They really did not want it to be a public open space that just anybody could come and go. Security was a big concern for them. So that was, again, this, what are the requirements? In the second workshop was then to start to get into more detail about what elements might people want in a garden. We did a demonstration of the concept of attenuation, which involved Imperial College professor Adrian Butler with a baking tray and some tea towels to pouring water over to show, what happens. So yeah, fairly simple hands-on stuff. And there were some other co-design games that my colleague Siwei Tay led to try and move the design forward into a bit more of a shape of what a garden might look like. And then in between, there were visits to other gardens. There was some effort to try and, at quite a distance for us, but to really encourage the community to figure out a way of organising themselves as a gardening group, to integrate the garden into the local tenants and residents association, these kinds of things. Also prototyping, so we moved the prototype from Meakin Estate to the rainwater harvesting prototype to the new estate again, so that people could see how it worked. People on the estate were concerned about vandalism. Our tank was vandalised, so these are all the, the kinds of detailed things that happened in between times. And then on the third workshop, we wanted to get down to more, again, more of this detail of what will it actually look like and what will the water implications be. So the other thing that's happening alongside these workshops in the background is the software design and the tool design to make tools to help to bring the engineering knowledge into these discussions. And this is the, very beta version of what we call the Kipling calculator. This was built by software engineers from British Geological Survey. They've taken this forward and developed it further, and this will be one of the big outcome, or a big outcome for the Camellia project overall, is a repository of all sorts of software tools, modelling tools, community engagement tools that they'll be launching, or, you know, they're in the final stages, if not already having launched this website where you can go and download various bits of software. One of which will be a more advanced version of this tool where residents could sit on a laptop and just drag a piece of garden, drag some social space, drag a rainwater harvesting unit. They get a bit of a sense of the layout of their garden. And then it also gives what's the attenuation benefit, how much storage have you, what percentage of the irrigation demand for this is met by the storage that you've put into your design. The upshot of that was that then meant that they had some evidence for the environmental benefits and also the viability of their garden, that they applied for funding to the Mayor of London to be able to start to build the garden. So that gave them $20,000 for phase one. What happened in the meantime was that it became, for other complicated reasons, not feasible to actually build on that site, but the residents have been able to repurpose those funds and have actually built a garden elsewhere on the estate. So it doesn't necessarily meet the rainwater potential that we wanted, but it has given them a process, some governance structures, and some funding to build their own garden. So in terms of this overall impact, or this overall experience with co-designing infrastructures, in terms of success, I think each of our projects has had some small or large benefit for the people that we've been involved with. So some of them have gotten a rainwater tank, others have gotten a hefty report that they can take to their local council to argue for stronger measures for better air quality. It has had some policy impacts on those local governments, and it's had, you know, really positive benefit, I think, for the engineers that have been involved. And we've been able to demonstrate that it is actually possible to engage local communities in some of these decisions and include technical information in those conversations about local environments. Some of the real constraints on it, though, are, you know, obviously these large socio-technical systems that we're talking about when we're talking about big infrastructures like water. There's massive, it's not just that the pipes are baked into the city, it's also the systems of governance and ownership and decision-making are very strong and powerful, and it's very difficult to achieve change. So we have to be very realistic about the scale and scope of what we can, you know, the ultimate impact of these very small interventions. From a community point of view, we come in and we might be working with them for 6 months or a year, or, you know, around that kind of time frame. And then we leave and they still are left with their ongoing struggle for better air quality or their ongoing struggle for a garden. So we are a short-term intervention in, you know, what is a long story for them. And although we have really tried to make our tools adaptable, and we've even tried ourselves to apply them in more resource-constrained contexts, the reality is that we have been very generously resourced as research teams. But we have managed to come out with these outputs, and this is one of the things that, well, this is the purpose of the book, really. And we also have a website, bottomupinfrastructure.org, which has these tools and processes. And, you know, this is one of those, is this overall co-design method. So yeah, just to end up, I think this co-design approach is one mechanism for resolving these complex urban challenges. It's feasible, but it is resource intensive, and in some ways it can help to highlight or spotlight those broader systems challenges and the challenges of achieving change. And it is a way for local communities to increase their own technical capacities to then hold more powerful actors to account. And so that's the website where a lot of this work is documented. And then the book that's coming out, those are my co-authors. That's the image that's on the cover. We haven't yet, we're just literally agreeing the final design of the cover. And UCL Press is hopefully where you'll find it, as I said, open access to download next April. If not, you can follow me on Twitter, and I'm not a very prolific tweeter, but I will be when the book comes out. So that's it. Thanks.